Please copy down the title, Chapter 3, Notes on Graphing a Function Form Equation Using an XY Table, which is also known as an Input-Output Table. Please copy down this title. Write down today's date. It's 11/29/2016. It is Tuesday. If we look at this first part, which I don't want you to copy down, just want you to read along with me here. It says, what is the solution to x plus 1 equals 3? So what's the answer? 2. Now, why is the answer 2? Because 2 plus 1 equals 3. It's the only number that'll fit right here that'll make it a true statement. All right? So if I take a look at the equation x plus y equals 3, then this one could be 2 and this one could be 1. Does that make sense? Yeah. So I would write my answer as x equals 2 and y equals 1. But instead of writing it as x equals 2 and y equals 1, let's write it as a coordinate 2, 1. Does that make sense? So for x plus y equals 3, the coordinate 2, 1 will be a solution. But there's really an infinite amount of answers, because 2 and 1 could give you 3. 3 and 0 could give you 3. I mean, if I go 4 and negative 1, that'll give me 3. 5 and negative 2, that'll give me 3. 6 and negative 4, 7 and negative 4, 8 and negative 5, and so on and so on. So there's an infinite amount of answers. Do you guys understand that? And right here on the typed up notes that I don't want you to even copy down, I explained that there's more than just the answer 2 and 3, or 2 and 1. So 2 plus 1 gives you 3, but there's also 3 and 0, 0, 3, 4, 4 negative 1, 5 negative 2, 6 negative 3, 7 negative 4, 8 negative 5, 9 negative 6, 10 negative 7, 11 negative 8, and so on and so on. You could even do 100 and negative 97. You could do 1,000 and negative 997, right? There's an infinite amount of answers. So I think you get the idea that there's infinite amount of answers to an equation that has two variables. And this is the reason why we graph, okay? Why do we graph? To represent the infinite amount of answers that exist to an equation. So do me a favor, on your notes, write down y graph, and write down the answer right there to represent the infinite amount of answers that exist to an equation. So why do we graph? To represent the infinite amount of answers that exist to an equation. So let me work through, once again, the equation x plus y equals 3, and let me think about the answers. Well, we said that the answer could be 2 plus 1. So 2, 1 is an answer. Or you could flip them and say 1, 2. Okay? You could also say 3, 0 is an answer. X equals 3, y equals 0. Or x is 0 and y is 3. Right? Or we could say 4 and negative 1, 5 and negative 2, and 6 and negative 3, and so on and so on. You could keep going forever, right? Or you could even flip them. Instead of 4 and negative 1, you could say negative 1 and 4. So all of these are answers. So when we graph, and all of these are points, when we graph, and on your notebook, I would like you to do a quick sketch of a XY plane. This is your x-axis, this is your y-axis. Do a quick sketch. And let me just plug in some of these answers. Let me maybe do a 2 and 1. Oh, I'm sorry. 2 and 1, 1 and 2, 3 and 0. Let me do a couple of these. 2 and 1, that would be 2 on the x, 1 on the y. It would be right here. Switching the 2 and the 1, it'd be a 1 and a 2. Okay, so it'd be a 1 on the x, 2 on the y, it'd be up here. Or we also said, how could we get 0? 3 as an answer. 0 plus 3, that would be the coordinate 0, 3. 0 on the x, 3 on the y. Or you could also switch it and say 3, 0, right? So 3 on the x, 0 on the y. 3 on the x, 1, 2, 3, 0 on the y. So it's right there. As you can see, it doesn't matter which point I graph on this graph over here, it's going to line up perfectly on that line. Does that make sense? So I draw a line through it and I put some arrows on it. Now, what does that mean? That the arrows, it means that it continues forever. So you could even say like this graph, you only see a piece of it. You only see 1, 2, 3, 4, 5. It only goes up to 5 on the x. But like we said, an answer to x plus y equals 3, it could also be 6 and negative 3. That could be an answer because 6 plus negative 3 is 3. Now, where would that be on the graph? It would be 6, 1, 2, 3, 4, 5, 6 off the graph, and negative 1, 2, 3 off the graph. But you notice that this dot over here does pass through right on that equation. So the arrows mean that it continues forever. So this line that we just graphed really does represent the infinite amount of answers that exist to an equation with two variables. Are you with me? Okay, so we got that basic, most important fact out of the way, that all the answers are coordinates, which graph a line. Oh yeah, one more final thing. It doesn't even have to be nice numbers. It could actually be a 1.5 plus 1.5. That'll also give me 3. So a solution is 1.5, comma 1.5. So if I did go to the graph, it would still be true. Because if I went 1.5 and I went 1.5, I would be on that line anyway. So this line really does represent every single answer that exists. Even if it's a decimal answer, like 1.5 and 1.5, it'll be on there. Okay. So down here it says, how many points do we need to actually draw a line? How many points do we need to actually draw a line? Do we need, how many did we do up here? We did a bunch of them. We did 1, 2, 3, 4, 5. Do we need 5 points? How many points do we need? 2. You only need 2. So let's write that fact down somewhere. Write down, you only need 2 points to graph a line. Only need 2 points to graph. That is ugly. I ran out of space. All I need 2 points to, whatever, you get the idea. You only need 2 points. You guys got that? So what I would like you to do now is write down the vocab word function form. Okay, so we already got down the first part of what we need to understand. Let's move on to the next part. Write down the words function form, and then write down those 3 definitions that you see right there. What is function form? It simply means to get y by itself. Or another way of looking at it is to solve for y. Or another way of looking at it, to isolate the y on one side. It's all the same thing, getting y by itself. That's what function form actually means. So please copy that down in your notebook. I mean, the word form itself means that it has a certain shape, it has a certain organization, right? If you fill out the form at the doctor's office, it probably has your name first, and then your address, and your age, and all this other stuff that's organized. So form is the organization of it, it's the way it looks. So when we look at an equation that's in function form, all that's saying is that it has to look like y equals something. Maybe y equals x plus 1, y equals 3x minus 2. As long as you have y by itself, that's technically function form. And we've already talked about functions and relations. Functions are nice. They're like a machine where you plug in inputs and you pull out outputs. My voice is going, sorry. So function form is simply getting y by itself. So if we understand what function form means, we should be able to, rewrite the following equations in function form. So do me a favor, I'm going to pause it right now so we don't kill video time, but please copy these guys down and let's work on them and get them all in function form. Let's get them all as y by itself on one side. So if you're at home doing this for the first time, hit pause, try to get y by itself, and then check out the work later. So on number 1, is it in function form? Yes. The answer is no. Because what does function form mean? Y by itself. Is y by itself on the left side of the equal sign? No, there's this big plus 2 right here. You don't want that plus 2. So you're going to do the opposite of plus 2, which is minus 2. That'll cancel it out. And what you do to one side, you have to do to the other side. Okay? So you're going to subtract 2 over here. So what do you have left? You have y all by itself, and that's what function form is. So you have y equals. Now, could you actually subtract 3x, take away 2? No, you can't. That's like saying I have 3 oranges. Let me take away 2 apples from it. You can't do it, right? Apples and oranges, different. So all you're going to do is rewrite it. 3x take away 2. Ladies and gentlemen, that is function form. You see? It's easy. Number 2 is y by itself. No, what do I need to do? Add 3x and add 3x. So I'm going to have now the function form equation y equals. Now, some people write it like this, 4 plus 3x. But the better option, mathematicians always like to be organized. So they always like, if there's just a nice number without a variable, that's called the constant. They like that at the end. So let's rearrange it. Let's get these guys and switch them, okay? So it's going to be y equals positive 3x plus 4. That's your final function form equation. I mean, technically, this guy is correct, y equals 4 plus 3x, but this is definitely better. X term first, the constant at the end. Let's move on to number 3. What do I have to do here? There. Divide by 2. So we're going to divide by 2, divide by 2, divide by 2. I'm dividing everything by 2. That way I could get y by itself. I'll have y equals, what is 2 divided by 2? 1. 1x. Okay, you don't even need the 1. You could just say y equals x. And then 6 divided by 2 is 3. And ladies and gentlemen, we're done. That's your function form equation right there. Let's try the next one. And of course, this is all on video. You'll be able to pause it from home when you watch this again, which I hope you'll do. Number 4. This one's really easy. Some people get confused. Function form. Is it in function form? No. You need y by itself. You don't want negative y. So you're either going to multiply everything by negative 1 or maybe divide everything by negative 1. Or you can just simply say, I want to change all the signs, right? I want to show my work as dividing by negative 1, dividing by negative 1, dividing by negative 1. So I will have y equals x divided by negative 1. That's just a negative x. Negative 5 divided by negative 1. That's really going to be what? Plus 5. That's right. So there's your function form for number 4. Moving on to number 5. I need to get y by itself. What do I need to do? Divide by 5. Boom. Divide everything by 5. Now, I really do have a function form equation here. I have y by itself equals, now the left side, you have 4/5. You really can't divide 4 by 5, so you're going to have to leave it as a fraction 4/5 with an x. And the 10 divided by 5, that really is 2, right? Now, the thing is, we like to have the y on the left side, not the right side. I mean, y does equal this, so let's just put the y over here in front and make it y equals 4/5 x minus 2. Having y by itself. That's the best function form equation you could have right there for number 5. And it's okay to have fractions. Let's do one more here. Is this one in function form? Yeah, it is. However, we could make it a little bit nicer by writing the constant term at the very end, the variable term before it. So let's move things around. Just make it the nicest way possible. It's going to be x plus 1. Cool? Got it? All right. So if, let's say, it would have been a negative 1. All right? Let's go back to this. Let's pretend it said y equals negative 1 plus x. Then you'd have to rewrite it as y equals x minus 1. Does that make sense? Because it's a positive x, there it is, positive x, and this is a negative 1, and that is a negative 1. If it were negative. Man, I made a mess. Okay, let's start another video actually graphing using an XY table. Yeah.